The first detailed close-up imagery of China's WS-21 turbofan engine, powering the Shenyang J-35 stealth fighter. Released in mid-December 2025 and rapidly circulating across defense-focused digital ecosystems, the imagery reveals the WS-21's serrated exhaust nozzles in unprecedented clarity, visually confirming long-suspected stealth-optimized design choices while reinforcing expert assessments that the engines or at least the exhaust nozzles are totally different, and that the WS-21 is an interim engine enabling faster induction of the J-35 while more advanced propulsion matures, echoing China's earlier evolutionary pathway with the J-20 program. Beyond the visual confirmation of nozzle geometry, the WS-21 imagery implicitly demonstrates that China has crossed a qualitative threshold in integrating stealth-centric propulsion with carrier-compatible structural design, a convergence that historically demanded decades of iterative learning within Western naval aviation communities. Taken together, the WS-21 close-ups indicate that China's naval aviation challenge to established carrier powers will not hinge on a single breakthrough technology, but on the cumulative effect of incremental propulsion maturity, accelerated force generation, and the disciplined alignment of industry, doctrine, and strategic intent. The WS-21 is a low-bypass, afterburning turbofan delivering approximately 93.2 kN of thrust with afterburner engagement, providing the J-35 with sufficient acceleration, sustained transonic performance, and carrier launch margins necessary for naval operations. Its estimated bypass ratio of 0.4 to 0.5 reflects a deliberate balance between fuel efficiency and high-energy maneuver performance, optimized for maritime patrol radii and quick-reaction intercept missions. The engine integrates a full-authority digital engine control system enabling precise thrust modulation across launch, recovery, and combat phases, an essential requirement for high-tempo carrier air wings. Advanced materials dominate the turbine section, with single crystal blades and thermal barrier coatings allowing elevated inlet temperatures that improve efficiency while preserving service life in corrosive maritime environments. The most visually striking feature revealed in the December imagery is the WS-21's serrated exhaust nozzle geometry, with jagged sawtooth petals engineered to scatter radar energy and promote rapid exhaust mixing to reduce infrared signature. This design directly targets modern multispectral detection systems, reducing vulnerability to infrared search and track sensors and long-range surface-to-air missile engagements in contested airspace. The absence of visible smoke residue in the imagery reinforces assessments that the WS-21 employs advanced combustor design to eliminate telltale exhaust trails, a non-negotiable attribute for survivability in fifth-generation air combat. While lacking thrust vectoring and true supercruise capability, the WS-21 prioritizes maturity, reliability, and stealth compatibility, enabling the J-35 to achieve Mach 1.8 while sustaining high sortie rates from carrier decks. In propulsion terms, the WS-21 is less a technological endpoint than a force-enabling catalyst. The operationalization of a WS-21-powered J-35 materially strengthens China's anti-access and area denial architecture by extending stealth air power from land bases into contested maritime zones.